Hello, I'm Sam.
I'm Nicholas.
And today we're excited to share a solution to a significant challenge faced by men.
So every day, many people have issues, whether it's due to aging, injury, or other conditions that limits their mobility, it limits their quality of life, and we designed a product to help with that.
And while there are solutions on the market, like accessibility aids, they often come at high costs and are cumbersome to use. And we wanted to make this basically to support those that don't have the extra resources to purchase those.
So our customers, the people that would use this are, everyday normal people. They don't have the time, they don't have the money, they don't have the skills to be able to learn new software, new arms, to be able to afford, expensive products.
Yeah, so that's why we developed this mechanical arm. It's controlled by a custom controller and then a custom PCB. We're thinking end goal with this, we wanted to change this controller up just to make it a little more accessible. It's still pretty easy to use, user-friendly, and it's a cost-effective product. I think our bill of materials was what, $30 total? But yeah.
So our goal is just to make it as accessible as possible and to make it efficient and easy to use.
Yeah, the aim of our solution is basically just to offer something accessible, efficient, and affordable to help these people who have lower mobility move around more freely and comfortably. So yeah, thank you. Hi guys, we're back. This video we're just basically going to show you the functionality, how everything works. So this is our custom controller we made. We made this originally for our Cobot, and then we turned it and repurposed it for this mechanical arm. So it's running off of a joystick and then two caps. So these guys are basically for fine-tuning movement. The joystick moves this guy up and down, and then this base side to side. And then these two are for the final movements. So this arm and then this spoon, so the actual utensil holder. Like I said, we're running it off the computer right now just to show basically how easy it is for anyone to like pick up maybe their phone, the end goal, or something like that, and customize the controls themselves. And then he's going to go a little bit into how this thing actually works.
So on the base of the robot here, we have a stepper motor, which drives the geared base. And then on the base, on the bottom here, we have a stepper motor to a large gear ratio to generate enough torque to be able to move the arm properly. And then up top here, we have another servo motor controlling this arm. This has a small gear ratio because this arm isn't that heavy, it doesn't need a lot of torque. And then we have a small servo motor up here controlling the spoon, just up and down. Okay. And then so demonstrating the functionality of the arm. So we have it like this. If you want to rotate the base, you see just like that. And these are easy to use commands, easy to use, easy to learn, So now for the arm, we move that up, we move it down. These are large movements just for the sake of demonstration. Okay, and then we move the base. Oops. There we go. As you can see, it all moves around. It's a little bit jerky right now. It's a little large movements, but for demonstration purposes, it works pretty well.
Yeah, and then like I said, at the end of this, we're going to just include a short clip of the controller setup, but we just wanted to show you how easy it is with the computer to control. So yeah.
So this is the first system. The base rotates, and then next up is the main arm servo, and then next up we have the secondary arm, and then we have the spoon on the end. Okay.
Hi, so now we're back. We're going to look more into how everything actually works. So here's our flow chart for our code. First start out by initializing everything. So this is like our base servo, arm servo, claw servo, how our rotate speed works. So you start out with this loop, goes down and checks if debug mode is on. If yes, prints the JS array. This is how we read all of our values in. If not, waits for a serial input. Still goes back, reads in from the serial input we get from here, and it prints in an S value. And then we go and check a conditional. So if S equals 1, 2, 3, 4, we set that number it's equal to our JSN out. And this is basically how we track all of our movements. So if you look down here, if it's less than 250, it goes down to yes. and it moves it counterclockwise forward, right, really anything positive. If no, it'll see if it's greater than 740. If it is, it moves it counterclockwise. If it's not, then it just goes back up to the begin loop. And then in the beginning of the loop, we also initialize the claw position with JS2. And now we're going to explain more of the actual code behind this. So here's some code snippets.
So more on the code. So we have all of our declaration stuff. We do pins, speed controls, servo stepper. We create our array, and then we have some control modes. So then we do setup. So this is serial, and this is attaching all the servos. So then for our loop, if we're using the controller, it reads controller values, and if we're using the computer, it reads computer values. So whatever the user inputs. So then if debug mode is true, it prints out the array just for debug purposes, so you can see what you're printing. And then now we just print values to servos. And then at the end, we have a delay, and then we just reset values, so we're ready to go again.
Yep.
So then onto the schematic. So as you can see here, we drew up a schematic for the custom PCB. So the Arduino Nano goes to all the pinouts. The big thing is we have two power rails. We have a 9-volt power rail coming from the USB-C, and we have a 5-volt power rail coming from the Arduino Nano. Mm-hmm. And then so after you create the schematic, you go through and you just place all the components. So then after the components are placed, you wire up all the traces, and then you just cut it. And then it is as easy as that.
Yep, and we made this in KiCad.
Yes.
And then here's the actual PCB, just take a look one more time.
And then on the bottom,
It's all soldered.
and then we have normal header pins so that they just interact with the servos properly.
Yep. And that's it.